Okay, so this impulse turbine, if you look at how it looks, is like you are having a storage or a large reservoir, and then you will drive the flow through the so-called a penstock. Okay, this is the penstock. So this is your lake or a reservoir. This is the lake of the reservoir, and then you drive the flow through the penstock, and then you will have a nozzle. The reason of having this nozzle is you want to have as high velocity as possible, because this impulse turbine is working based on the kinetic energy provided by the jet. So you will have a jet, and this jet will strike the bucket. So this will strike the bucket. Let me open my ruler first. Okay, so since you are having this kind of condition, right, you can expect that to analyze this, you will have to get the velocity of the jet here. So the properties or the power generated by this turbine is strongly dependent on this. The velocity of jet striking the turbine. Okay, let me open that one first, and then we will go to the example, right? Because that will be easier for me rather than to. No, I cannot even open my Ulan here. Okay, this I do not know whether my computer is slowing down or the internet is one create problem. Your internet? Sure. Not my computer.
Yes.
Tell me my computer, then I can throw this computer back. Okay, so if you open the Euler, you will see that for this kind of turbine, the power generated will be. Can you open that in your Euler? W soft is equal to? W shaft is equal to rho r omega q. Is it big R or small r? Small r, right? Bracket Vz
Minus R omega
r omega close bracket. Another bracket 1 minus beta.
1 minus cos beta.
1 minus cos beta. Why don't I make that thing become a big whiteboard for me? Yeah. Okay. because it is useless for us now. Let's make it useful, right? Yeah. Finally, I got a big whiteboard for me. Okay, so let me open that. Okay, so your W sub is rho R omega Q fidget RW times 1 minus cos beta. Okay, so basically those beta come from the deflection of your water. Okay, now when we are talking about the impulse turbine, when you are talking about this Pelton turbine, the water is directed through the penstock and then it will emerge as a jet from the nozzle, right? So this nozzle will strike the bucket and it will drive the flow. Okay, if you remember in your Fluid Mechanics 1 chapter 5 conservation of momentum, okay, the biggest force you can get is when you strike something. Let's say this one is your fin. I'm not sure whether your lecture gives you this equation or this question or not. You are having a jet, right? You are having a jet from the nozzle, and then it strikes a fin, right? It strikes a fin, and you need something to hold it, anchoring force. The biggest anchoring force you will obtain when you make it bending so that the jet will goes back. Correct. Because then in this case, you know that m dot in V in, m dot is always negative. You know why it is negative? Because n is always there and V in is always there, right? So this one is this time that dot point dot calculation will become negative. That's why you get m in is negative. V in this case is positive, right? And then you have the m out. M out is usually positive because the n is pointing outward and then V is pointing outward. So you get that one is positive. Okay? But then this velocity is pointing to the negative x direction. So this one becomes minus V out is equal to F. Right? So this is the maximum force you can get. Similarly for the Pelton turbine, you want the jet to hit it and then goes back. Right? You want it to hit and then goes back. But you will never get it. Why? Because this turbine is moving. Right? When it strikes, you do not want the water, the bound water, to hit the next blade. Can you imagine? Now you have a bucket moving. You hit it. You hit with the water. You want it to coming back 90 degree. When you have that, of course it will hit the next bucket. Right? So what they do is they optimize it. If you look at the bucket of the Pelton turbine, we have there. It is not like your plate like this, no. But it is like a heart shape, right? Heart shape, and it will be chipped on top of it. You will see there is some hole there, right? Okay. So the reason for that is that it looks like from this side, from that side, it looks like you have this, and then it's broken like that. Of course, this one is welded. It will look like this. You know why? The reason is when the water strikes, it will deflect that to that side. So the next bucket is not disturbed by the reflecting water. Now you got the reason why it's like that. And you know why it is like that? So that the next bucket is like that from here. Right? So when the jet coming, you give them a hole. So it will not strike this because you want to strike that. So it will strike those, hit that, move, then the next one come, hit this. Okay? And you cannot make it directly back. 180. Why you want 180? Because when you have 180, this cos will become -1. Negative, negative, positive. So you get 2. Okay? So you want it to be 180, which means you want it to be reflected back. That is the maximum power you can gain from this Pelton turbine, but you will never get it, right? So engineers has come up with the optimum one. The optimum is 165. That is the optimum. Okay? Of course, in the calculation, in our class, sometime I will tell you, calculate the maximum or the maximum ideal power. In that case, you put cos omega equal to 180. I mean, like the beta is 180. That one is ideal value. But if I ask you the maximum actual, usually it's about 165. Okay? So, when we are talking about that, this is your shaft power, right? It will be ideal if this one is equal to 180. Okay? One more thing, the theoretical maximum value will be achieved when your... Okay, now when you have this turbine is always moving. Okay, this turbine is rotating at the speed of omega. So the omega you find there is the rotation of the turbine. Okay, so this one is the rotation of the turbine. Now, if you want to get the maximum theoretical value, you will achieve it when you set phi jet equal to, when you set the omega or the rotation of the turbine, when you set this omega equal to phi jet over 2r. Okay, and r is the radius of the bucket. Okay, so you will get the maximum power when you set omega equal to phi jet over 2r and beta as close as possible to 180. That is the only way you can get it. Okay?